Now we'll deal with the process of creating user interfaces. There are two basic approaches to interface creation. We may create an interface from the Java code level or from the level of XML files. The second approach is much more popular. But to start with, we'll focus on the first method to show how they are related. The slide below illustrates how to create a fragment of a layout with a button. Everything is created from the code level. Now let's return to our source code and remove the setContentView method, which so far has been used to create the new view. Instead, let's call our own method, setContentView. This method is present in two variants. The first one was present here until now, and it uses the ID of the resource. Inside it, we provide a link to the resource, which has to be loaded as a layout. In our case, it's the activity_hello.xml file. There is also a second approach, which makes it possible to set a specific view created from the Java code. The button we'll create may be a sample view. Each view needs a context. We may place getApplicationContext, as we did a while ago, or use an activity, which also implements the context. If we go for the simplest solution, we may pass the button as the main view for our entire application. The task of the setContentView method is to set the view which will occupy the entire screen. After launching such an application, we'll get a view with a single button and no text. Note that it occupied the entire available activity area. We may change certain properties of the created button. For instance, to set a text, we just need to call the appropriate methods. The setText method makes it possible to set a specific text on the button. If we want to change the size of the button inside our layout, we must pass the layout parameters. For this purpose, we create a relevant layout params. This object exists in many variants, depending on the layout which we want to place our view on. The default layout, where we place elements, is the frame layout. When creating such an object, we may, for instance, specify its height and width. In order to specify the values to be occupied by the inserted object during the insertion, we have to pass the created layout params as the second parameter. After starting such an application, we get a button with a size of 100 by 100 and the text button. Currently, the text is so big that it doesn't fit inside the button, and that's why it's wrapped. In this case, the best solution is to specify the layout width not as a specific value, but by using a special constant wrap content. It tells us that the width has to be equal to as much as it is necessary for the entire button content to fit inside. We get a version where the button includes the whole text. The height is still 100 pixels. This parameter may also be changed to wrap content. Now let's assume a more complex situation. We want to have two buttons with different names, one under the other. To do so, we need to create two buttons and set a different text on the second button. Both buttons need to be placed inside the layout. For now, we're able to set only one view as the main one for our application. If we want to place several views next to one another in a specific configuration, we must use the layout whose task is to package the views which we get as a single view. A simple example of a layout which fulfills our requirements is the linear layout. The linear layout itself is also a view, but its main task is to store other views. Other views may be added to a new layout using the add view method. For the time being, we won't need layout params. We must set our linear layout as the main view for the entire application. Our main view will be the linear layout, which includes two buttons. We got what we wanted. We have two buttons next to each other. If we wanted to have two views one under the other, we'd have to call the setOrientation method with the vertical parameter on our linear layout. Thanks to this, we have views placed one under the other.